This video is about sinusoidal transformations. These are transformations of a sine function or a cosine function. This is AP Precalculus topic 3.6. If you appreciate this content, please give it a like. Number 1. The graph of the sinusoidal function h is shown in the figure above. The function h can be written as h of theta is equal to a times the sine of b theta plus d. Find the values of the constants a, b, and d. The full model for h of theta would include theta plus c, where the opposite of c would be the phase shift. The fact that this model does not include a plus c means that the c is equal to 0. There is no phase shift. That means that one period of this function starts right at theta equals 0, like this. This is upside down compared to the parent function y equals sine theta. That tells us that the a value will be a negative number. Specifically, the a value will be the opposite of the amplitude. The amplitude is the distance from the midline to the highest value. In this case, the amplitude is 2. Therefore, the a value will be negative 2 in this case. Now it's time to find the b value. We have memorized that b is equal to 2 pi divided by the period. This period starts at 0 and ends at 2 pi. So the period of f is 2 pi. That means that the b value will be 2 pi divided by 2 pi. So b is equal to 1, which we don't really even need to fill in. Finally, the value of d corresponds to the midline. Since the midline is at y equals negative 1, then the d value is negative 1. But let's just write this as minus 1. So a is equal to negative 2, b is equal to 1, c is equal to 0, and d is equal to negative 1. Let's do the same thing for number 2. Again, notice the missing value of c. That means that c is equal to 0 and there is no phase shift. That means that one period of the function will begin right at 0 like this. This period is right side up compared to the parent function, so the a value will be a positive number. Specifically, the a value will equal the amplitude, which is 3, the distance from the midline to the highest value. So the a value is positive 3. We can find the b value by taking 2 pi divided by the period. This period begins at 0 and ends at 4, so the period is 4. That means that the b value is 2 pi divided by 4. This simplifies to pi over 2, so that is the value of b. The d value corresponds to the midline. Since the midline is at y equals 1, the d value is 1. So a equals 3, b equals pi over 2, c equals 0, and d equals 1. Let's do the same thing again for number 3. Again, there is no c value, meaning that c is equal to 0, meaning that there is no phase shift. Therefore, one period of this function will start right at 0 like this. We have memorized that the parent function y equals cosine theta looks like this, and this period is upside down compared to the parent function, so the a value will be a negative number. Specifically, the a value will be the opposite of the amplitude. Since the amplitude is 3, the distance from the midline to the highest value, the a value will be negative 3. The b value is given by 2 pi divided by the period. This period starts at 0 and ends at pi over 2, so the period is pi over 2. Therefore, the b value will equal 2 pi divided by pi over 2, When you divide by a fraction, you multiply by the reciprocal. So b will equal 2 pi times 2 over pi. These pi's will cancel each other out because you have one high and one low. That will leave behind 2 times 2, and the b value is 4. The d value corresponds to the midline. Since the midline is at y equals -1, the d value will be -1. So a is -3, b is 4, c is 0, and d is -1. Number 4. The figure shows the graph of a sinusoidal function h. What are the values of the period and amplitude of h? One period of h starts right at x equals 0. So, since this period starts at 0 and ends at pi over 2, that means that the period is pi over 2. The amplitude is the distance between the midline and the highest value. Be careful, this is not 3, because on the y-axis we are counting by 5s. So you can think of this as the highest value minus the value of the midline. So this is 10 minus -5, which is the same as 10 plus 5, which is 15. So the period is pi over 2, and the amplitude is 15. Therefore, the answer is D. Number 5. The trigonometric function k has a maximum at the point 0, 20. After this maximum, the next minimum occurs at the point 4 pi, 10. Which of the following could be an expression for k of x? In previous videos, we have learned that the horizontal distance between consecutive max and min is always half the period. This is a lot to write, so I like to express the horizontal distance between consecutive max and min as theta 2 minus theta 1, where theta 2 and theta 1 are the input values of consecutive max and min. Multiplying both sides of this equation by 2 gives us a formula for the period. The period will equal 2 times theta 2 minus theta 1. So we can always find the period by doubling the horizontal distance between consecutive max and min. In this case, the input values for consecutive max and min are 0 and 4 pi. So the period will be twice the distance between these two. So 2 times 4 pi minus 0. Obviously the 0 is not doing anything, so we have a period of 2 times 4 pi, which is 8 pi. We can use this to find the b value. We have learned that the b value is given by 2 pi divided by the period. So in this case, b will equal 2 pi divided by 8 pi. The pi's cancel out, and the 2 over 8 reduces to 1/4. So that's the b value, which matches options B and C. So we can eliminate A and D. Let's see. A difference between B and C is the A value. So let's calculate the A value, which corresponds to the amplitude. We know that the amplitude is the maximum value minus the middle value. From these equations, they all have a midline of 15. So we can do the maximum value, which is 20, minus the middle value, which is obviously 15. The A value will equal the amplitude in this case. They are all positive values. So 20 minus 15 is 5. So the correct answer is B. Number 6. The trigonometric function k has a maximum at the point pi over 2, 6. After this maximum, the next minimum occurs at the point
pi comma negative 2. Which of the following could be an expression for k of x? We have learned that the period is double the horizontal distance between consecutive max and min. In this case, the period will equal 2 times pi minus pi over 2. We need like denominators, so I'm going to think of pi as 2 pi over 2. So we have 2 times 2 pi over 2 minus 1 pi over 2 is simply pi over 2. The 2's cancel out, and we get a period of pi. We can use this period to find the b value, because we know that b is equal to 2 pi divided by the period. So in this case, b is equal to 2 pi over pi. Now the pi's cancel out, leaving b equals 2. So options B and C both have a b value of 2, but options A and D do not. So we can eliminate those options. We notice that options B and C have different amplitudes. So let's calculate the amplitude based on what we know and see which one of these is correct. We know that the amplitude is equal to the maximum value minus the middle value. The maximum value is 6 because we are told that k has a maximum at this point. The middle value will be the d value, and both of the remaining options, in fact all of the options, have a d value of 2. So that is the middle value. So the amplitude, which will equal the a value, will equal the maximum value of 6 minus the middle value of 2. So the a value should equal 4. So that's why the answer is C. Number 7. The trigonometric function k has a minimum at the point 0, negative 10. After this minimum, the next maximum occurs at the point pi, 20. Which of the following could be an expression for k of x? Last time we found the b value and used that to narrow down the options, but this time all of the options have a b value of 1. So that wouldn't help us. We will not waste our time there. We do notice that we have different d values. We have different midlines. So let's use the information we have to calculate the correct midline and use that to eliminate 2 of these options. The middle value, the d value, is the average of the max and min. So that's max plus min divided by 2. The maximum value is 20, and the minimum value is negative 10. So the d value will equal 1/2 20 plus negative 10, or 20 minus 10. So that means the d value is 1/2 of 10, which of course means that the d value is 5. So we have narrowed it down to either A or C, which have the correct value of d. We can throw out options B and D. What is different about option A and option C? Both of them are cosine functions, and they both have the same d value. But option A has a negative a value, whereas option C has a positive a value. The parent function y equals cosine theta is oriented like this. So if the graph turns out to be oriented this way, that will correspond to a positive a value. If the graph turns out to be upside down compared to the parent function, that will correspond to a negative a value. We are told that k of x has a minimum at the point 0, negative 10. So the period begins at a low point. Half of a period later, we reach a maximum value of pi, 20. So this will be pi right here. Let me label it real quick. This will be the point pi, 20. This is half the period, so half the period is going to look like this. If we kept going, the other half of the period would look like this. This corresponds to a negative a value. This graph is upside down compared to the parent function. So that means the answer is A. Number 8. In Seattle, the number of daylight hours is dependent on the day of the year. The number of daylight hours, d, can be modeled by the sinusoidal function d of t is equal to 4.1 sine of 0.024 times t minus 79 plus 11.7, where t is the day of the year from t equals 1 to t equals 365. Based on this model, which of the following statements is correct? We notice that the d value is 11.7, so the midline is y equals 11.7. We notice that the amplitude is 4.1, so the maximum value will be the middle value plus this amplitude. 11.7 plus 4.1 is 15.8, so that is the maximum value. Similarly, 11.7 minus 4.1 gives a minimum value of 7.6. We notice that the c value is negative 79. Therefore, the phase shift will be the opposite of c, which is positive 79. That means that one period of d of t begins at 79. And this is a sine function with a positive a value. So, starting at 79, d of t will be oriented just like the parent function. It will be the right side up version of the sine function. Option A says the minimum number of daylight hours in Seattle is 11.7 hours. But 11.7 is the middle number of daylight hours, not the minimum. That would be 7.6. So A is out. Option B says the maximum number of daylight hours is 15.8 hours. That is true. So the answer is B. But just for the sake of thoroughness and completeness, let's look at option C and D. The minimum number of daylight hours occurs on day 79. Nope. The sine function starts at the midline. Option D says the maximum number of daylight hours occurs on day 79. Again, this is the middle number, not the maximum. Number 9. The figure shows the graph of a sinusoidal function g. Write an equation for g. The graph of g has a shape that matches the parent function y equals cosine theta. So let's use a cosine function to model g, and we know that the a value will be positive because g is right side up compared to the parent function. Also, the period of g that we're given begins right at 0. That means no phase shift, so the c value is 0. So we don't need to leave space for a plus c. In this case, the a value will equal the amplitude, which is the distance between the middle value and the maximum value. The amplitude is 3, so the a value will be 3. We have memorized that the b value is equal to 2 pi divided by the period. This period of g starts at 0 and ends at pi, so the period is pi. Therefore, the b value will equal 2 pi divided by pi. The pi's cancel out, leaving b is equal to 2. And that b value goes right here. Finally, the d value just comes from the midline, which is y equals negative 1. So we'll finish it off with a minus 1. That's it for number 9. Number 10. The function f is given by f of x equals 2 times the sine of 2x plus 1. Which of the following could be the graph of f of x? We notice that the d value is 1, So the midline should be y equals 1. All of the graphs have a midline of y equals 1, except option B, which has a midline of y equals 2. That's wrong, so B is out. We notice that the c value is 0. That means we're looking at a sine function with no phase shift. So starting right from 0, we should be looking at a graph that has the same shape as the parent function y equals sine theta. So D has the shape of the parent function y equals cosine theta, not sine theta. So D is out. Both of the remaining options have an amplitude of 2, which matches the a value that we see. However, the period is different for option A and option C. We can use the period to find the b value and see which one of these matches the b value of 2. We have memorized that the b value is equal to 2 pi divided by the period. In the case of option A, the period is pi. So the b value should equal 2 pi divided by pi. These pi's cancel each other out, so we should get a b value of 2. And that is correct, so the answer is going to be A. But let's follow through and look at option C. For option C, the period is 4 pi. So the b value would be 2 pi divided by 4 pi. And that gives us a b value of 1/2 because the pi's cancel out and 2 over 4 reduces down to 1/2, which is not a match. So C cannot be the answer. Number 11. The figure shows the graph of a trigonometric function g. Which of the following could be an expression for g of x? Let's take it one option at a time. Option A has a c value of 0. That means no phase shift. So option A should have one period that begins right at 0. This is a sine function with a positive a value. So one period of option A should look something like this. Let's see if the b value of g matches the b value of option A. We know that the b value is equal to 2 pi divided by the period. This period of g is pi. It goes from 0 to pi. So the b value of g should be 2 pi divided by pi. The pi's cancel out, leaving b is equal to 2. Option A has a b value of 1. So A cannot be the answer. The rest of the options do have a b value of 2. Option B has a c value of negative pi over 2. Therefore, the phase shift is positive pi over 2. That means one period of option B will start right here at pi over 2. The period of g that starts at pi over 2 looks like this. This is upside down compared to the parent function, so this should correspond to a negative a value. B has a positive a value, so B cannot be the answer. Option C has the same c value, therefore the same phase shift of positive pi over 2. So we have the same period to look at, and as we discussed, this is upside down compared to the parent function, so this should correspond to a negative a value, and we do have a negative a value. So C is probably the answer. But let's follow through and see why D is not the answer. Option D has a c value of negative pi, therefore a phase shift of positive pi. So one period of option D will begin right here at pi. The period that begins at pi is right side up compared to the parent function, so this should correspond to a positive a value. D has a negative a value, so D could not be the answer, confirming that the answer is C.
Number 12. The graph of H and its dashed midline for 2 full cycles is shown. 5 points F, G, J, K, and P are labeled on the graph. No scale is indicated and no axes are presented. The coordinates for the 5 points F, G, J, K, and P are given here. The function h can be written in the form h of t equals a times the sine of b times t plus c plus d. Find the values of the constants a, b, c, and d. We have memorized that one period of the parent function y equals sine theta looks like this. So it'll be easiest to write an equation for h of t if we base the equation on a period that looks just like this. Since this period is right side up compared to the parent function, the a value will simply be the amplitude, the vertical distance between the maximum value and the midline. So in this case, that'll be 7 minus 3, which is 4. So the a value is 4. It's almost time to find the b value, but for that we need the period. From maximum value to maximum value, we go from an input value of 0 to an input value of 12. That gives us a period of 12. We know that the b value is given by 2 pi divided by the period. So in this case, the b value will equal 2 pi divided by 12. This reduces to pi over 6. So that's the b value. Now it's time for the c value, which will always be the opposite of the phase shift. And the phase shift is just the first input value. So as we look at how the input values are changing, 0 to 3 to 6 to 9 to 12, successive input values are increasing by 3 each time. That means if I move to the left, I'm going to be decreasing by 3. So this input value will be negative 3. This is the point negative 3, comma 3. It'll have the same y value as these other points that are on the midline. So because the first input value of the period is negative 3, the c value will be the opposite of this. This is the phase shift. The c value will be the opposite of the phase shift, which will be positive 3. The d value corresponds to the midline. Since the midline is at y equals 3, based on all of these output values, then the d value is 3. That's the end of number 12. You can either record your answer like this, or leave it like this. Number 13 is the same problem with different input-output pairs. Let's again write an equation for h of t based on a period that is shaped just like the parent function y equals sine theta. In that case, the a value will simply be the amplitude, which is the maximum value minus the value of the midline. In this case, 20 minus 16 gives an a value of 4. Next, it is time for the b value, but in order to find the b value, we first need the period. From maximum to maximum, the input values go from 0 to 4 pi. So that is the period. We know that the b value is going to be 2 pi divided by the period, so 2 pi over 4 pi. This simplifies to 1/2 after the pi's cancel out. So the value of b is 1/2. The c value will be the opposite of the phase shift, and the phase shift is the first input value. So as we examine the input values and how they change from 0 to pi to 2 pi to 3 pi to 4 pi, we see that every successive input value is increasing by pi compared to the previous. So if I go to the left, I should decrease the input value by pi. So the very first input value of this period will be negative pi. This is the point negative pi comma 16 based on the output values of the other points on the midline. Since the phase shift is negative pi, the C value is positive pi. The D value simply corresponds to the midline, so the D value is positive 16. And that's it for number 13. You can either record your answer like this, or just leave it like this. Number 14 is once again the same problem, except with different input-output pairs. Let's write our equation for h of t based on this period of the function, which looks just like the parent function y equals sine theta. That way the a value will simply be the amplitude, the difference between the highest value and the value of the midline. In this case, 2 minus negative 1, which is 2 plus 1, which is 3. So that is the a value. For the b value, we're going to need the period. The input value at the maximum here is pi over 2. The input value of the next maximum is 3 pi over 2. So the period will be the difference in these input values. 3 pi over 2 minus 1 pi over 2 is 2 pi over 2. The 2's cancel out, and the period is pi. The b value is given by 2 pi divided by the period. So in this case, that'll be 2 pi divided by pi. Those pi's will cancel out, giving us a b value of 2. The c value is the opposite of the phase shift, which is right here. The input value of j is pi, but you can think of this input value as 4 pi over 4. So we have 4 pi over 4. The previous input value is 3 pi over 4, and you can think of this input value as 2 pi over 4, which reduces down to pi over 2. So if I go from 4 pi over 4 to 3 pi over 4 to 2 pi over 4, then the next input value to the left will be 1 pi over 4, or simply pi over 4. Pi over 4 comma negative 1 for the midline. Since the phase shift is positive pi over 4, the c value will be negative pi over 4. These are always opposites. The d value simply corresponds to the midline, which is at y equals negative 1. So the d value is negative 1. And that's it for number 14. You can either record your answer like this, or leave it like this. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.